Hello and welcome to a demonstration of the Classifier Configuration tool within ImageFlow. This is a multi-featured tool which is involved heavily in many other tools within ImageFlow, including blob analysis, adaptive surface inspection, and print inspection. So if I access the tool through the adaptive surface inspection here, you'll see that the first screen is where you define the different classes of defect you want to have in your inspection. So I can right click on classes here and add a class, and I can call it defect test. And now I can add the class parameters which I want the class defect test to be defined by. So I can add area here, and then I can now define a min and a max area value which the defect has to fall between in order to be classified as a defect test. So you'll see the two other boxes of information here. You have a tabular indication of measurement statistics and a graphical indication. The measurement statistics indicates the min, max, mean, and standard deviation value of the current class parameter you have selected in this current frame. So that's telling me that the minimum area of defect in this frame is 1, the maximum area is 851, the mean area is 12.1146, and the standard deviation of area is 68.7945. Now the histogram shows me a graphical representation of the measurement statistics found of the used measurement in this frame. So as you can see from this histogram, it's telling me that 150 defects were found that had the area between 0 and 100. So once I'm happy with the value of one class parameter that I've defined, I can add another class parameter to the class. So for example, I can say the center of mass. So for this value, the center of mass means that the center of the defect has to fall within a certain range. So you can see here on the histogram the distribution of defects along the x-axis. So if I set the minimum center of mass x to be 2000, only defects more than 2000 will be shown. So I can set that here. So I can set the min to 2000 and the max to 8000. So now only defects with a center of mass x greater than 2000 are shown on the display image. So as you can see, every defect shown in the histogram to have a center of mass less than 2000 is no longer shown on the live image. So the user can then add as many class parameters to be used on one class as possible, and then all measurements have to be a match in order for a defect to be shown as a member of that class. Other points of interest on this interface are the display image, the overlay, and the approximate classifier processing time. So the display image toggles between binary and grayscale. So binary is just a black image with any defect shown in a different color, and the grayscale is the original image with the found defects shown as an overlay. And the overlay can be results or indices. So results are the results of the classifier that you've defined here, and indices are simply every possible defect that could be shown. The approximate classifier processing time is the time which ImageflowTM estimates it would take for this classifier inspection to complete. So the next tab of interest in the classifier configuration interface is the measurement table. So the measurement table is simply a tabular representation of all the different points of interest that were found on the web. So you'll notice that all the columns here represent two possible measurements we could have used in the class parameters screen. So there's the center of mass X that we used and the area. So if I go back to classes and right click, you can also all of these measurements have entries in this measurement table. You'll also notice that if I change the overlay from results to indices, you'll see that all the numbers here correspond to a defect that was found. So if I click 36 here, you'll notice that this index 36 corresponds to this entry in the table. So all this data corresponds to that point of interest. So the next tab that you can use in the classifier configuration interface is filter zones. Filter zones are area of the web which for some reason are to be ignored. For example, if you knew there was a defect that was going to be there, but it was there for a reason, or there was something else that was on the web that you wanted ignored. So if you hit edit filter zones here, and I can add a new filter zone. So we only have one possible class that we've set up, so it'll come up as all classes being in this filter zone. But if we had 2 or 3 or 4, we'd just add the classes that we want to be ignored and leave those there. So now the filter zone is at its default coordinates of 0, 0, 0, 0. But if I were to draw a box around here, then it would take those coordinates and apply the filter zone in that box. So I can add or remove as many filter zones as I want by clicking these 2 buttons, and I can select and deselect all as needs be. So if I hit the tick button, it saves the filter zones, and if I hit cancel, it cancels saving. Just for demonstration purposes, I'll press OK, and you'll see the filter zone is now in there. But since we don't actually need a filter zone for this inspection, I'll go back in and I'll remove it, and it'll be gone from the filter zone menu. The next tab of interest in the classifier configuration interface is the pre-processing tab. Pre-processing is using morphology in order to decrease the classifier processing time. There are a few different options here. You can use erosion, dilation, opening, or closing. And erosion eliminates pixels isolated in the background and erodes the contour of particles. Dilation eliminates tiny holes isolated in particles and expands the particle contours. An opening is an erosion followed by a dilation and removes small particles and smooths boundaries. The closing function is a dilation followed by an erosion. So it's a matter of trying the different morphology types and keeping an eye on the approximate classifier processing time and see if any of them manage to improve that. As you can see for us, since the inspection we're doing is not too intensive, the pre-processing, the advantage that a preprocessor would give is negligible enough. So you can try to change the number of iterations for the erosion and dilation, see if that makes any difference. But it actually only makes the processing time bigger. And you can change the kernel size for the opening and closing functions, but once again, that doesn't make much difference. But for operations with large amounts of defects and very high resolution images with high densities of defects, a pre-processing and morphology might be of interest. All these morphology concepts are available in the NI Vision concepts manuals, which you can find online. The final tab on the classifier configuration screen is the Miscellaneous tab, and this allows the user to add additional measurements into the class parameters screen. So as it stands, we have center of mass, we have the width, area, center of mass, intensity, and so on. And through this additional measurements screen, we can add in different types of measurements we want to get from each inspection. And there's, as you can see, there's a vast variety of different additional measurements you can choose from. And all these are also can be found on the NI Vision Concepts site. So there's a link to that on um, the Onebox Vision ImageflowTM help page. So you can reference that for information on all these different types of measurements. Thanks for listening to this demonstration.